Alright, we're about to start talking about a specific way to solve differential equations, but before we do, I want to talk a little bit about what solutions to differential equations can look like. So all I'm going to do is go through some examples of determining first whether or not a function is a solution to a differential equation, and I'm going to look very specifically. I want to know if A, B, and C are solutions to this equation here. Y double prime, which is the second derivative of y, minus my function y equals 0. So all I'm going to do is find the parts I need. So the first thing I'm going to need is y double prime. So I'm going to go ahead and say that y prime, the derivative of sine, is cosine of x. And the second derivative is negative sine x. Well, now I have the two things I need. I have my y and I have my y prime. I'm going to go ahead and plug them into this equation, giving me negative sine x minus sine x. And I want to know, does that equal 0? Since it does not equal 0, this would not be a solution. If I look at the second one, part B, if I'm going to go ahead and do the same thing, I need the same parts, so I'm using the same equation. Excuse me. I see that y prime would equal, well, notice because it is e to the negative x, I'm going to let u equal negative x and v equal 4e to the negative x, and then u prime equals negative 1, v prime, 4e to the u, and v prime equals 4e to the u. So my first derivative is going to be negative 4e to the u, and finding my second derivative, I'm going to go ahead and do the same thing. So since I have, this was supposed to be negative x, putting my u back in. Since I'm essentially differentiating the same equation, the only difference is now I have negative 4 instead of positive 4. I know it's going to differentiate the same way. So when this becomes a negative negative, it's going to become 4e to the negative x. So now I ask myself, does it follow that original equation that I was given? So I have y double prime minus y prime. It does equal 0, so yes, it is a solution. And then finally on the last term, y equals c e to the x, where c is just some random constant. So if I do the same thing with this, first thing I do is I find my first derivative. So I know y prime is just going to be c e to the x. So just like my constant here of 4 stayed, my constant here of c is going to stay. And notice this time I don't have to use the chain rule because it is just an x. And then y double prime will be also c e to the x. So y double prime, rewrite that so you can read it, c e to the x minus y, which is c e to the x, does equal 0. So yes, that is a solution. Down here more is my second example. Suppose you were told that x times y prime minus 3y equals 0, and that you are told that this y equals cx cubed is a solution to my given differential equation. Can you verify that statement and then find the particular solution if x equals negative 3 and y equals 2? So, in order to verify that this actually is a solution to this equation here, I'm going to need to again find out what is y prime, what is my first derivative. So I know that y prime is going to be 3cx squared. I'm going to go ahead and plug into this equation. I get x times 3cx squared minus 3y, does it equal 0? Because if this is a solution. Well, that gives me 3cx cubed minus 3. I forgot to plug my y back in, which is cx cubed. Well, notice that I am subtracting the same thing, so that does equal 0, so it does work. So there, I have now verified that it is a solution. Now, finding a particular solution, we have done this before. Remember, what I'm going to do here is that I'm going to solve for c. That's what it means to find my particular solution. So I'm going to go ahead and plug -3 in for x and 2 in for y, giving me 2 equals c times -3 cubed, which is 2 equals c times -27. So c equals -2 over 27, and my particular solution is y equals -2/27 x cubed. And lastly, what if instead of determining if a given equation is a solution or verifying a solution, what if you were actually asked to find the solution? Do you remember what that means? We've done this before, so this should be a review for you. So notice I'm asking to solve the differential equation for both the general solution and the particular solution if f of 1 equals 4. So my given differential equation is y prime equals 3x squared minus 2x. So in order to solve this, in order to find out what y is, I am going to integrate my differential equation. Doing this gives me y equals 3 over 3x cubed minus 2 over 2x squared plus c. This would be my general solution. My particular solution, then solving for c, so f of 1 equals 4. I'm being told that x is 1, y is 4, and I get 4 equals 1 cubed minus 1 plus c. So c equals 4, giving me my particular solution of y equals x cubed minus x squared plus 4. And there would be my particular solution. That's it. And we're going to continue to do this. We're going to learn a new method for solving differential equations called separation of variables, and that is what you will watch next.